159.
Vehicle power internal.
155.
Launch sequencer start.
150.
Securing Centaur LO2. Securing Centaur LH2.
140.
Launch enable.
FTS armed.
$120.
Orca's armed.
SCS count started.
Produce ECS for launch.
Roger.
110.
Vent valves locked.
T-minus 1 minute and counting.
Report range status.
Range status green.
Stay at step 3.
T-minus 30 seconds and counting.
28.
ECS reduced for launch.
25.
Roger. Status check.
Go Atlas.
Go Centaur.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Main engine start, 0, and liftoff of the Atlas V with Curiosity, seeking clues to the planetary puzzle about life on Mars.
The program is in right on time. 180 operating at 100% thrust as expected. And throttling down to 76%. Program is complete. And MSL is now breaking the sound barrier. SRB chamber pressures following the nominal curve. Everything will. And we passed through max Q. We're on closed loop on Atlas PU. Signatures as expected. SRB profile continues to look nominal. Throttling back up to 100% thrust on the RD-180. Engine parameters looking good. Flight control disturbances look as expected. SRB pressures running right as expected. Coming up on SRB burnout, we have burnout of the SRBs. Everything is looking good. 10 seconds to SRB jet. And we have first pair and second pair. Both sets of SRBs have successfully jettisoned the vehicle. We've re-enabled guidance. Everything is looking good.
This is Rob Gannon, our United Launch Alliance Telemetry Manager. We're hearing.
Vehicle is now 32 nautical miles in altitude, 54 miles downrange, traveling at 4,900 miles per hour. And we've throttled down to hold a constant 2.5 G level for payload fairing jettison. And we fired the pyro valve, pressurizing the RCS bottle. Pressure increasing in the loop as expected. Now we're hitting our 2.5 G limit, coming up on payload fairing jettison, approximately 10 seconds. Fairing jet. And we also have a successful CFLR jettison, right as expected. Throttling up on the RD-180, everything looking good. Coming up to 89% thrust. And we are now entering our constant 4.6 G acceleration throttle phase. Everything looking good. We've started boost phase chill down. Housing temps are responding. Coming up on booster engine cutoff. Expecting BECO in 10 seconds. Safety ADUs. We have BECO, retro rockets, and stage separation. We have pre-start on fuel and locks. Ignition and full thrust. Centaur main engine is up and running as expected. Everything looking good. Steering has been enabled. We have Centaur PU to fixed angles, right as expected. And we've begun our reaction control system thermal conditioning firings. Everything looking good. And the vehicle is now 102 nautical miles in altitude, 570 miles downrange, traveling at 13,700 miles per hour. And we're now in the early portions of a nearly 7-minute first burn of Centaur. Engine continues to operate normally, good steady state operating pressures. Engine continues to burn normally, seeing loop temps come up in the RCS system as we continue our thermal conditioning firings. Good AGCs on the FTS system. Approaching RF disable.
This is the telemetry lab at NASA Hangar AE,
Atlas performance,
where all the data is coming in from the flight.
And we are rolling to TDRS.
Acquisition now through the Tracking and Data Relay Satellite System, TDRS East.
And we're continuing to roll to TDRS. Total of 75-degree change in attitude. Have switched to the Centaur-only format quite a few seconds ago. And we've achieved our TDRS attitude, roll rates coming back in. Engine continues to look good.
We've lost signal here at the Cape, as expected. Now using Antigua data.
And passing 470 seconds into the mission, everything looking good. And the vehicle's 150 miles in altitude, 1,250 miles downrange, traveling at 15,000 miles per hour. And we are seeing nice smooth responses from the flight control system. Body rates are smooth and very close to zero. We are accelerating at a steady 0.47 Gs. Engine continues to operate smoothly. And Centaur PU is in closed loop control, but continues to ride the stop as expected. And engine operating parameters continue to look good, nice and smooth.
Centaur engine cutoff coming up in 2 minutes.
We have 2 minutes to MECO 1. Vehicle's 151 miles in altitude, 1,648 miles downrange, traveling at 16,100 miles per hour. And taking a quick look at the range track, the vehicle is flying right down the projected path. Everything looking good there. We are now 1 minute to a nominal MECO 1. Expecting an IP vanish in approximately 40 seconds. And the engine continues to operate nominally. Centaur PU has come off the stop. It is actively controlling.
Peters East is ready for the handoff from Antigua.
Chamber pressures look good. RCS temps reacting as expected. Steadied out. Ten seconds to MECO 1. We have cutoff. Normal shutdown signatures. We have 4S engines on as expected.
Cutoff was right on time. Handing off
FDS
now
is
from
safe.
Antigua to Peters East.
And we've begun our turn to MES 2 attitude. Starting to spin up Centaur in roll for our PTC roll. Taking a quick look, tank pressures are right as expected. Helium storage bottle pressures over 3,000 psi, looking good. Main battery voltage looks good. And we've achieved our 1.5 degree per second roll rate for our PTC roll.
This is Atlas Launch Control, 12 minutes 45 seconds into the flight. We had Centaur engine cutoff right on time at T plus 11 minutes and 30 seconds. And we are now in a parking orbit of 102 by 201 nautical miles. And we are underway with a 19 minute and 35 second coast phase, after which the Centaur will come up for a second and final time for an 8-minute burn to put it on planetary trajectory. We're going to show now some of the different camera angles of the launch of the Atlas V from different vantage points around Kennedy Space Center and Cape Canaveral Air Force Station. And we should have several different shots that will present different vantage points that will be particularly unusual from the standpoint of cameras that we have not used in the past. So we will begin right now with the launch replays.
We are continuing to see expected tank ullage pressure changes throughout coast phase. Battery voltages, storage bottle pressures, looking good. We are experiencing a data loss at this time. And we are seeing a little more data loss than expected. For coast phase, do have data back at this time, and everything looks good.
Right now our data is coming through the Tetris East satellite and will be acquiring at Hartebeestok once the vehicle is over South Africa at 32 minutes 9 seconds into the mission.
Down to a 25% duty cycle. We have active data back here, and all levels look good for coast phase. And everything continues to look good for coast phase. And we're continuing to experience frequent data losses. When we do get some clean data back, all levels are as expected. And we've now got data back. Quick check, all levels look as expected. Other loss of data. And we've now steadied out at our 25% duty cycle on settling thrusters. And we received information. The spacecraft is already power positive. We are continuing to see periodic data dropouts, though everything does look as expected when we do have acquisition of signal. And at this point in time in the mission, we should be seeing a PTC roll reversal, though we've not had data to confirm that. And we're approaching 1,300 seconds into the mission. Everything continues to look good. We are seeing expected levels in our bus battery voltages, as well as our storage bottles and propellant tanks. Body rates are looking good. And the next significant event we're looking for is a 2.5 second liquid oxygen flush through the propellant feed lines to condition the feed line for second burn. About 1 minute away from that.